Today we're looking at 3D trigonometry. So your goal is to investigate and use concepts of 3D trigonometry, three-dimensional trigonometry, to solve a problem. So the first step for 3D trigonometry is you want to draw a picture if they haven't drawn one for you. Now 3D drawing in itself is quite a difficult skill. So that might take you a little bit to handle that. So I'm going to skip past step 1 today, and I'm going to do an example with a drawing already done. This example, it wants us to find the length AD. So this length over here. So after we've done the first step, drawing the picture, we've identified the side we want. What do you think is the next step? So we want to find the height. But before we do that, we need to split our diagram. So most 3D diagrams, you're going to split them into 2 triangles. And the first triangle is triangle ACB, or ABC. We know it's a right angle with 12 on one side and 35-degree angle. Split it into the 2 triangles. That's when we use trigonometry twice. So we're trying to find AB. So you could call this X if you want. Another way to do it is just call it AB. So we want to find what AB is. Have you guys seen this notation before, AB with a line over the top? So some of you may have seen this. This just says AB is a line. Alright, so we've got an angle, we want to find the opposite, and we also know the adjacent. So what opposite adjacent is? Very good. Tan theta is opposite over adjacent. So sub in the angle, sub in the sides. The opposite is AB. The adjacent is 12. And then multiply both sides by 12, and you have AB by itself, because we've eliminated the 12 on the bottom. Now, this is the bit you need to pay attention to. Most people, I reckon, would then put that into their calculator. Why do we not then put that into the calculator? Very good. You guys figured it out? We want to keep it exact. We don't want any rounding errors. So we can just leave AB equal to that. That's what AB is equal to. If you want to put it into your calculator and have this big long decimal, you can do it that way as well, but just don't round it. So write yourself a note. I've solved for one side, and now we're going to solve for another side. We've got the angle, we've got the opposite, and we want the hypotenuse. Opposite and hypotenuse involves, so we're using sine this time. Sine theta, or we can call it sine alpha, just sine of the angle is equal to opposite over hypotenuse. So we know the angle is 23, we know the opposite is exactly 12 tan 35 degrees, and we know the hypotenuse is, oh, that's the bit we don't know, AD. So then we multiply both sides by AD and divide both sides by sine 23 degrees. So then you can type all of that into your calculator and you'll get an answer for AD. So yes, you should have got, and let's go to 2 decimal places, approximately 21.50. Very good, meters. Something to think about. Let's imagine this was a complex question. When you get your answer, you want to think about, is it realistic? So is 21.5 meters a realistic length for that blue line AD? Like if it was 2,000 meters, it's probably not realistic if, you know, another length is 12 meters.